Continuing with section 1.4, we have 5 different scenarios where numbers are increasing, and we want to know, the question is the growth linear? Is the growth exponential or neither? It's either linear or exponential or neither. Linear means it goes up by the same amount every year. Okay, so this is where we would want some extra paper here. Let's look at question number 1, scenario 1. The best way to do this is to start at the bottom and work your way up. This is actually miles, not years. So let's check for linear. Is the difference, which is subtraction, the same for all rows or between all rows? If the difference is the same between all rows, then it is linear growth. So what is 1530 minus 1290? After 5 miles minus after 4 miles. 1530 minus 1290 on the calculator is 240. So now I want to see the difference between the 4th and 3rd row. So we're going to do 1290 minus 1050. If this is not $2.40, we can just stop and say it is not linear. But on your calculator, 1290 minus 1050 is 240. So we might be having linear growth here for question number 7. You have to do every row and column. So now we're going to start at 1050 and subtract 810, the difference between those two rows, which still is 240, continuing to look linear. So now let's look at the difference between 810 and 570. When you do that on your calculator, you get 240. And the difference between my starting point and 1 mile, between 570 and 330, is 240. Since the difference is the same between each of the rows, this is a $2.40 increase, this is a $2.40 increase, $2.40 increase, $2.40 increase, $2.40 increase. We can say this is linear growth. It goes up by the same amount after every mile. And the question was, find the next value on the list. So we could say after 6 miles, this is going to be 1530 plus 240, which is going to be 1770. So for linear growth, the amount you add to each row is the same. But the way we're going to find that is we actually start at the bottom and subtract. I think that's the easiest way to do that. All right, let's look at scenario 8. Here's scenario 8, and we have our starting point, and then after 1 year, 2 year, it's going up by year. So first we want to see, is there the difference between each row the same? And we start at the bottom. So the difference between the 5th and the 4th year, so that's going to be 19,326 and 12 cents, and then I'm going to minus 17,569 and 20 cents. And I've already done that on the calculator. The difference there is 1,000 $756.92. So basically, I want to see now if the difference between the third and the fourth year is $1,756.92. So we're going to have $17,569.20 and subtract this number, I'm sorry, I said the wrong word, $15,972 even. And when you subtract that, you get $1,597.20. These are not the same. So this is not linear. The increase from 3 to 4 is not the same as the increase from 4 to 5. So this is not linear. So now we're going to go to our second possibility, which is this exponential? Exponential. With exponential growth, I take whatever I multiply the starting point by to get the first year. Is that the same number if I take 1320 multiply by the same number to get the second year? So I'm multiplying. Is there a common multiple going from rows? Now, once again, the easiest way to do this is to work from the bottom. The opposite or the inverse operation of multiplication is division. So we're going to do 1,900,326.12 and divide that by the row above it, 17,569.20. And when you do that on your calculator, you get 1.1. So we actually want to see if when I divide the fourth row by the third row, do I also get 1.1? Do I also get 1.1? So it's a pretty tedious, but we're going to do it. So what is 17,569.20 divided by 15,972? And I've done all this already. When you divide, you get 1.1. So far it's looking like this might be exponential growth. So now we'll do 15,972 divided by 14,520. And when you do that calculation, you do get 1.1. All right, so we have just two more calculations to do here. Let's go to this, the difference between the first, after the first and the second year. So that's going to be 14,520 divided by the number above it, 13,200. And you know what you get? 1.1. And our last check, what is 13,200 divided by 12,000? And you get 1.1. So this multiplied by 1.1 gives you this value. This multiplied by 1.1 gives you this value. This multiplied by 1.1 gives you this value. So this is exponential growth. This first one was linear. And it went up by 240 every row. This one is exponential. And we multiply by 1.1, a factor of 1.1, which means, remember in our previous example, 1.05 was the whole plus a 5% increase. This is like 1 plus 10%, which is an exponential growth of 10%. So this is exponential. The question didn't ask us, but I went ahead and solved it anyway. This number after the 1 is the amount of growth. This is a 10% growth. 0.10 made as a percentage is 10%. And if they want the next row, so now after 6 years, that's going to be 19,326.12 times 1.1. 19,326 times 1.1 is now $21,258.73. So this is the process you're going to follow for all of these. First, subtract, 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 subtract. See if you have a common difference. And if you do, that is linear growth. If it's not linear, then you would do divide, 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 divide. See if you have a common factor. And if you do, then it's exponential. If it is neither linear nor exponential, you would answer neither. So I'm going to leave performing that for 9, 10, 11, and 12 to you. But the first thing I did is subtract, and I got the difference was 217. And then these two rows I subtracted and got 212. Not linear. And so then I did 11,041 divided by 10,824. Then I did 10,824 divided by 10,612. And you know what? I did get 1.02 for all of the between the rows. That times 1.02. That times 1.02 would give me the next row. That times 1.02. So I did get a common factor of 1.02. So this is exponential 0.02 is 2%. Exponential 2% growth. And here after 6 years, the value for number 9 would be $11,262. It's a whole number. Now I want you to go through these calculations, but this one was exponential growth. Number 10. This one was linear. And the difference between the rows was $1,500. So after 6 years, 47,500 plus 1,500, that's going to be $49,000. And for number 11, the difference between 60 and 52 was 8. The difference between 52 and 48 is 4. It is not linear. And so now, what is 60 divided by 52? 1.153. Now what is 52 divided by 48? 1.08. Okay, it's not exponential either. So we would say this is neither linear nor exponential. So there's no way we can determine what would happen after 6 months.